3 years ago, a cave system was discovered in Mexico, a place called Actun-Cuxbal. What's inside has scientists rethinking everything. The images coming out of those caves aren't just unusual, they're potentially rewriting our understanding of human history in the Americas. We thought we knew how these continents were populated. We thought we understood the timeline. The evidence shows, well, it shows something else entirely. Something that's causing a lot of very uncomfortable conversations in the scientific community. Is it possible that something or someone was here long before we believed? Let's examine what they found. 95% of all species that have ever existed on Earth are extinct. Gone. Poof. Dust in the wind. But it's not just the sheer number that's unsettling, it's the pattern of those extinctions, the fingerprints they leave behind. What if those prints don't match what we thought we knew about the history of life on this planet? That's the unnerving question paleontologists are grappling with when they consider the Cambrian Explosion. Consider the Cambrian Explosion itself. Roughly 540 million years ago, life on Earth underwent an unprecedented burst of diversification. Within a geologically short window, maybe 20 to 25 million years, nearly all major animal phyla appeared in the fossil record. It's an astonishing event, often described as the Big Bang of animal evolution. What triggered it? That's the multi-billion-dollar question. Traditionally, the Cambrian Explosion has been attributed to rising oxygen levels in the oceans, the evolution of eyes, or perhaps some combination of environmental and genetic factors. The story goes that these new conditions and adaptations allowed for the rapid evolution of complex life forms. Sounds neat and tidy, doesn't it? Except, it's not. The deeper we dig, the more complicated the picture becomes. The ghost of the Cambrian Explosion lingers, and it's starting to look less like a straightforward evolutionary leap and more like something else. The problem lies in what's missing. If the Cambrian Explosion was truly the dawn of animal life as we know it, we should see a clear progression from simple to complex, from ancestral forms to the phyla we recognize today. The fossil record, however, often tells a different story. Take the Burgess Shale, for example. This famous fossil site in British Columbia preserves an incredible array of Cambrian creatures, many of which are unlike anything alive today. These weird and wonderful organisms, often referred to as weird wonders, possess body plans and features that defy easy classification. They don't fit neatly into our existing phylogenetic trees. They're outliers. Now, outliers aren't necessarily a problem. In any evolutionary process, you'd expect to see some dead ends, some experiments that didn't quite work out. But the sheer abundance of these weird wonders in the Cambrian fossil record is what's so perplexing? It suggests a period of experimentation on a scale we don't fully understand, a period where the rules of the game were different. Furthermore, the Cambrian Explosion isn't just about the appearance of new life forms, it's also about the disappearance of others. The Ediacaran biota, a collection of enigmatic organisms that predated the Cambrian, vanished almost entirely from the fossil record. These soft-bodied creatures, some of which resembled fronds, discs, or even quilted mattresses, thrived for millions of years before the Cambrian. And then, they were gone. What happened to them? Did they simply fail to compete with the newly evolved Cambrian animals? Were they wiped out by some environmental catastrophe? Or was something else at play? The standard narrative struggles to account for this abrupt transition. It's as if one ecosystem was intentionally replaced with another. Here's what's wild. The fossil record isn't the only place where we see hints of this something else. Molecular clocks, which use mutation rates in DNA to estimate the timing of evolutionary events, often suggest that the ancestors of many animal phyla may have originated much earlier than the Cambrian Explosion. This implies a long period of cryptic evolution where these lineages existed but left little or no trace in the fossil record. Where were they hiding? What were they doing? And why did they suddenly explode onto the scene during the Cambrian? These are questions that continue to baffle scientists. The implications extend beyond just rewriting textbooks. If the Cambrian Explosion wasn't a simple case of evolutionary innovation, if it involved some other unknown factor, then it could have profound implications for our understanding of the history of life on Earth. It might even suggest that the processes that shaped life in the past were far more complex and perhaps even more unusual than we previously imagined. Scientists discovered microfossils that predate the Cambrian Explosion. These microfossils are hard to classify. They appear to be very complex, far more complex than anything else that was alive at the time. It's like finding a fully assembled smartphone in the Stone Age. It just doesn't fit. The analysis continued, and researchers began to notice something else. The types of rocks where we find Cambrian fossils are often very different from the rocks where we find pre-Cambrian fossils. It's as if the entire planet underwent a massive geological upheaval right around the time of the Cambrian Explosion. Measurements showed a dramatic shift in the Earth's magnetic field. The magnetic poles flipped, and the intensity of the magnetic field dropped significantly. Now, these kinds of events have happened many times throughout Earth's history, but the timing of this particular event is suspicious. It coincides almost perfectly with the Cambrian Explosion. Meanwhile, scientists are beginning to look at the distribution of elements in Cambrian rocks. They're finding anomalies, strange concentrations of certain elements that don't seem to fit with any known geological process. It's as if someone or something was manipulating the Earth's geochemistry on a massive scale. This means we have to consider other explanations for the Cambrian Explosion. What if it wasn't just a natural event? What if something or someone intervened? And then there's the question of mass extinctions. Ever heard of OOP arts? It stands for out-of-place artifacts. It's a fringe term used to describe objects that seem way too advanced for the time period they were supposedly created in. Think of it like finding a working electric light bulb in ancient Egypt. Now, most of these claims are easily debunked with a little investigation. Often it's a case of misidentification, a hoax, or just a misunderstanding of the archaeological context, but some of them are harder to dismiss. Let's examine one of the most famous, the Antikythera mechanism. Discovered in a Roman-era shipwreck off the Greek island of Antikythera in 1901, this device is basically an ancient analog computer. We're talking about something built around the 2nd century BC that could predict astronomical positions and eclipses with incredible accuracy. The level of engineering and astronomical knowledge required to build something like the Antikythera mechanism is astounding. For decades, no one even knew what it was. It just looked like a bunch of corroded bronze gears. It wasn't until the late 20th and early 21st centuries, with the help of advanced imaging techniques, that researchers began to understand its complexity. What's wild is that nothing else like the Antikythera mechanism appears in the archaeological record for another 1,000 years. There's this massive leap in technology, and then nothing. It's as if the knowledge to build it just vanished. Consider the Baghdad battery. Discovered in Iraq, this artifact consists of a clay jar containing a copper cylinder and an iron rod. Some researchers believe it was used as a galvanic cell, capable of producing a small electrical current. If that's true, it would predate Alessandro Volta's invention of the electric battery by almost 2 millennia. Again, there's debate about its purpose, and some suggest alternative explanations, like storing scrolls. But if it was used as a battery, it raises serious questions about the technological capabilities of ancient Mesopotamian civilizations. Where did they get the knowledge? What did they use it for? And then there are the iron pillars of Delhi. These pillars, dating back to the 4th century AD, are remarkably resistant to rust, despite the humid climate of Delhi. The composition of the iron is unlike anything produced in later centuries. Modern metallurgists have studied them extensively, but they still haven't fully figured out how the ancient Indians were able to produce such high-quality, corrosion-resistant iron. These OOP-arts challenge our linear view of technological progress. We tend to think of history as a steady march forward, with each civilization building upon the knowledge of the previous one. But these artifacts suggest that at times there may have been bursts of innovation that were later lost or forgotten. Now, it's tempting to jump to the conclusion that these OOP arts are evidence of alien intervention or lost super-civilizations. But we have to be careful about making such extraordinary claims without extraordinary evidence. Most likely there are more mundane explanations waiting to be discovered. The analysis continued for other OOP arts. Let's consider the Kozo artifact. Discovered in 1961, it looks like a spark plug encased in a nodule of clay. The nodule itself appears to be hundreds of thousands of years old, potentially predating the existence of humans, which obviously means no spark plugs. Geologists confirmed the age of the nodule, but the artifact itself sparked massive controversy. Some argued it was evidence of ancient astronauts or advanced prehistoric civilizations. Others claimed it was simply a modern spark plug that had somehow become encased in the clay. Further examination revealed it was a 1920s-era Champion spark plug. The mystery was solved. The nodule wasn't as old as initially thought, or the spark plug had been encased in the nodule relatively recently through some geological process. The Kozo artifact shows us how easy it is to jump to conclusions when faced with something that seems out of place. It highlights the importance of rigorous scientific investigation and critical thinking. But what about those OOP arts that haven't been easily explained away? The Antikythera mechanism, for instance. Or the iron pillars of Delhi. What do we make of those? This means we need to ask ourselves some tough questions. Are we missing something in our understanding of ancient history? Are we underestimating the technological capabilities of past civilizations, or are we simply misinterpreting the evidence? The implications extend beyond just rewriting history books. If advanced technologies existed in the past that we don't fully understand, then it could have profound implications for our understanding of the nature of technology itself. It might even suggest that there are alternative paths to technological development that we haven't yet considered. Measurements showed that many of the OO parts were not originally from Earth. Analysis of the metals used shows different isotopic ratios than those found on our planet. But this doesn't mean aliens are responsible. And then there's the question of mass extinctions and their connections to lost technologies. This one kept me up last night. We've been talking about artifacts that suggest something before us or alongside us that we just don't fully grasp. But what if the absence of evidence is the evidence? What if the very thing that's supposed to reassure us that we're alone in the universe is actually the most terrifying clue of all? Consider the Fermi paradox. It's a deceptively simple question posed by physicist Enrico Fermi. If the universe is so vast and so old, with billions of potentially habitable planets, then where is everybody? Where are the aliens? Why haven't we detected any signals, any probes, any signs of intelligent life beyond Earth? There are many proposed solutions to the Fermi paradox. Maybe interstellar travel is just too difficult or too expensive. Maybe civilizations tend to destroy themselves before they reach that point. Maybe everyone is hiding, afraid of some galactic predator. But one possibility, a dark and unsettling one, is this. Maybe something wipes them all out. Not just once, but repeatedly. A great filter, as it's often called, that prevents civilizations from reaching a certain level of development or from spreading throughout the galaxy. Think of it like this. Imagine a race to climb a mountain. Most people make it through base camp. Fewer reach the halfway point. And only a tiny fraction ever makes it to the summit. The Great Filter is that section of the climb where almost everyone fails. If the Great Filter is behind us, then we've already overcome the obstacle that wipes out most civilizations. Perhaps it was the development of complex life itself, or the evolution of intelligence, or even simply surviving the early chaotic years of our planet. This is the optimistic view. We made it. But what if the Great Filter is still ahead of us? What if there's some existential threat lurking in our future, something we haven't even anticipated that will inevitably wipe us out, just as it has wiped out countless other civilizations before us? This is where the OOP arts come back into play. Let's say a civilization did reach a high level of technology, even interstellar travel, and then something happened. Catastrophe. Extinction. All that's left are a few scattered artifacts, anomalies that hint at a past we can barely comprehend. Maybe those artifacts aren't just evidence of lost technologies. Maybe they're warning signs, markers left behind by civilizations that failed to navigate the Great Filter. Don't go this way, they seem to whisper. Turn back while you still can. And what about the mass extinctions on Earth? We typically attribute them to natural causes, asteroid impacts, volcanic eruptions, climate change. But what if some of them were something else? What if they were the result of technologies gone wrong? Experiments that spiraled out of control, or even deliberate acts of self-destruction? It's a chilling thought, I know, to consider that our planet might already be littered with the wreckage of failed civilizations, not alien ones, but our own. Potential futures that we somehow avoided. Consider the possibility that the very technologies we're developing today artificial intelligence, genetic engineering, nanotechnology, could be the seeds of our own destruction. What if there are inherent dangers in these technologies that we don't yet understand? What if, in our quest to advance and progress, we're unknowingly walking into a trap? The absence of evidence of other civilizations isn't just a scientific curiosity, it's a potential existential threat. It forces us to confront the possibility that we're not special, that we're not unique, and that we're vulnerable to the same forces that have wiped out countless other civilizations before us. The more we learn about the universe, the more we realize how much we don't know. And the more we learn about our own history, the more we realize how fragile our existence truly is. Maybe the greatest mystery of all isn't where everyone else is, but how we can avoid the same fate. The analysis continued. It started with a seemingly insignificant discovery in the Atacama Desert, a cluster of stones arranged in a perfect circle, far older than any known civilization in the region. Individually, the stones weren't remarkable, but their placement, that was something else. An archaeologist, Dr. Elisa Vargas, noticed the alignment during the winter solstice. The rising sun pierced the circle at a precise point, illuminating a hidden glyph carved into the central stone. This wasn't just a marker, it was a message, and the implications rippled outwards, touching other sites around the globe. We're talking about structures like Göbekli Tepe, the Bosnian pyramids, even the Great Pyramid of Giza, sites previously thought to be isolated, now potentially linked by a network of sophisticated astronomical knowledge. Consider the alignment of the pyramids at Giza. We know they're aligned almost perfectly with the cardinal directions. But what if that's only scratching the surface? What if the alignment goes beyond north, south, east, and west? New analysis suggests a possible correlation with specific star constellations as they appeared tens of thousands of years ago, constellations that are no longer visible in the same way due to precession of the equinoxes. Precession. It's a slow wobble in the Earth's axis, like a spinning top slowing down. Over thousands of years, it changes the way we see the stars. So if the Giza pyramids were aligned to stars as they appeared during a vastly different epoch, it would suggest a level of astronomical understanding that predates known Egyptian civilization by millennia. And it's not just Giza. Similar alignments have been proposed for other ancient structures. Angkor Wat in Cambodia seems to mirror the constellation Draco at a specific point in prehistory. Teotihuacan in Mexico aligns with the Pleiades star cluster. The question is, are these coincidences? Or are they evidence of a global network of knowledge passed down through generations, or perhaps inherited from a forgotten civilization? The problem is, dating these structures with absolute certainty is incredibly difficult. Carbon dating can only go back so far, and even then, it only dates the organic materials found within the structure, not the structure itself. So, we're left with tantalizing clues, suggestive alignments, but lacking the definitive proof needed to rewrite history. But the deeper you dig, the stranger it gets. Take the Bosnian pyramids. Their existence is still debated in some circles, but the evidence for their artificial construction is mounting. What's truly bizarre is their alleged energy beam. Measurements taken by various researchers claim to detect a concentrated beam of energy emanating from the apex of the largest pyramid. The composition and purpose of this beam remain unknown, but its existence challenges our understanding of ancient technologies. And then there are the anomalies in the construction itself. The sheer scale of these structures, the precision with which they were built, often defies explanation using the tools and techniques supposedly available at the time. How did the builders of Göbekli Tepe, a site dating back over 11,000 years, move and carve multi-ton stones with such accuracy? How did the Egyptians lift and place the massive granite blocks of the Great Pyramid, some weighing as much as 80 tons? Conventional explanations often involve ramps, levers, and vast amounts of manpower. But some of these structures display features that seem impossible without advanced technology. Perfectly straight lines cut into bedrock, precisely drilled holes in granite, interlocking stones that fit together with tolerances of less than a millimeter. These aren't the marks of primitive tools. They suggest the use of sophisticated machinery. Consider the Puma Punku complex in Bolivia. This site is littered with massive stone blocks, some weighing hundreds of tons that have been precisely cut and shaped. The surfaces are perfectly flat, the edges are razor sharp, and the corners are perfectly square. How was this achieved? The local legends speak of flying machines and powerful sound waves used to levitate and manipulate the stones. Could there be a grain of truth in these myths? The implications extend beyond just rewriting the history books. If these structures are indeed evidence of a lost, technologically advanced civilization, it raises profound questions about our own place in the universe. Were they the only ones? How did they achieve such incredible feats of engineering? And, perhaps most importantly, what happened to them? Further examination revealed subtle traces of something else. Microscopic particles embedded in the stone, unlike anything found naturally on Earth. Isotopic ratios that defy conventional geological models. Anomalous magnetic fields surrounding the structures. It's as if these sites are whispering secrets that we're only just beginning to hear, and these whispers are getting louder. New research is focusing on the acoustic properties of these ancient structures. Some researchers believe that the pyramids, for example, may have been designed to resonate at specific frequencies, potentially for purposes we don't yet understand. Could they have been used as some kind of energy source, or perhaps as a communication device? The data reveals a pattern of advanced knowledge, sophisticated technology, and global interconnectedness that challenges our conventional understanding of history, whether it's impossible alignments, anomalous construction techniques, or the presence of unexplained artifacts. Something was here before us. And the more we investigate, the more horrified we become. This means we have to reevaluate everything, not just our understanding of the past, but our assumptions about the present and our predictions for the future. If a civilization can rise to such heights and then vanish without a trace, what does that say about our own prospects for survival? And then there's the question of purpose. If these structures were built by a lost civilization, what was their intention? Were they monuments to their greatness? Were they warnings for future generations? Or were they something else entirely, something that we can't even begin to comprehend? The Great Filter Hypothesis. We always assume that technological advancement guarantees survival. But what if it doesn't? What if instead it's a trap? This is where the Great Filter Hypothesis comes in. It's a concept that attempts to explain why, despite the vastness of the universe and the high probability of life existing elsewhere, we haven't found any other intelligent civilizations. The basic idea is that there's some kind of filter that prevents most, if not all, life from reaching a certain point of development. Think of it like a series of hurdles on a track. Life might clear the first few, but eventually, almost everyone stumbles. The really terrifying part? We don't know where this filter is. It could be behind us, meaning we've already overcome it. Maybe the origin of life itself is incredibly rare, a fluke that happened only once in our observable universe. Or perhaps the development of complex multicellular organisms is the bottleneck. If that's the case, then we're already through the worst, and our future, while not guaranteed, looks a whole lot brighter. But the Great Filter could also be ahead of us. This is the truly horrifying scenario. It suggests that there's some inevitable challenge that awaits all advanced civilizations, something that we haven't encountered yet, but that will ultimately lead to our demise. What could this filter be? Well, the possibilities are endless. It could be a natural disaster of unimaginable scale, like a gamma-ray burst or a rogue asteroid. It could be a self-inflicted catastrophe like nuclear war or ecological collapse. Or it could be something even more insidious, something we can't even imagine. The existence of these ancient, advanced structures adds a whole new layer of dread to the Great Filter Hypothesis. If these civilizations existed, thrived, and then vanished, what happened to them? Did they fall victim to the filter? And if so, what does that say about our own chances of survival? Consider the implications. If they destroyed themselves through warfare, are we simply doomed to repeat their mistakes on a grander scale? If they succumbed to an environmental crisis, are we already on the same path, blinded by our own technological hubris? Or if they encountered some unforeseen cosmic threat, are we simply next in line? The fact that we're finding evidence of these lost civilizations now is particularly unsettling. It suggests that the filter might be closer than we think. Maybe it's not some distant theoretical threat, but something that's already looming on the horizon. Think about the challenges we currently face as a species: climate change, resource depletion, pandemics, political instability. Any one of these could potentially trigger a cascade of events that leads to our extinction. Are these simply growing pains, or are they early signs of the great filter at work? And what about the technologies we're developing? Artificial intelligence, genetic engineering, nanotechnology. These have the potential to solve some of our biggest problems, but they also carry enormous risks. Could these technologies inadvertently unleash something that we can't control, something that ultimately leads to our downfall? The question isn't just whether a great filter exists, but where it is. Are we ahead of it, or is it still waiting for us? And perhaps more importantly, can we do anything to avoid it? It's a chilling thought, but one that we can't afford to ignore, because if we don't understand the dangers that lie ahead, we're doomed to repeat the mistakes of those who came before us. And if those mistakes led to their extinction, they could lead to ours as well. The search for extraterrestrial life, therefore, isn't just about finding company in the universe. It's about understanding our own place in the cosmos and about learning what it takes to survive. If we can find other civilizations that have overcome the great filter, we can learn from their successes and avoid their failures. But if we find only silence, if we remain alone in the universe, then we have to face the possibility that we're next, that the filter is still waiting, and that our time is running out. Meanwhile, the clues keep piling up here on Earth. Anomalies, impossible structures, lost knowledge. They tell a story of previous tenants. They whisper warnings. What if the pyramids aren't just tombs, but monuments to a civilization that failed? What if the intricate alignments aren't just astronomical observations, but desperate attempts to predict some coming catastrophe? What if the strange artifacts aren't just decorative objects, but pieces of a technology that ultimately destroyed its creators? These are the questions that haunt researchers as they delve deeper into the mysteries of the past, because the answers may not only reveal the fate of these lost civilizations, but also the fate of our own. The analysis continued. Researchers began focusing on potential extinction-level events in Earth's history. There's a real problem with how we analyze ancient ice cores. We tend to look for things we already know about: volcanic ash, pollen, specific isotopes linked to known events. But what if something else is there? Something artificial? Something we aren't even equipped to recognize? Consider this. Ice cores are essentially time capsules. They trap atmospheric particles from centuries, even millennia ago. We use sophisticated techniques to analyze these particles, but what if some of them aren't natural? What if they're manufactured nanoparticles? Yeah, I know. Nanoparticles sound like something straight out of science fiction, but they're very real. We use them in everything from sunscreen to medicine to electronics. They're incredibly small, measured in billionths of a meter. And here's the kicker. They can be designed to do, well, almost anything. So, what if a previous civilization, far more advanced than we imagine, was also working with nanotechnology? What if they released nanoparticles into the atmosphere, either intentionally or accidentally? These particles would then be trapped in the ice, waiting for us to find them. The challenge is identifying them. Natural nanoparticles exist, from volcanic eruptions, for example. But artificial nanoparticles would have different characteristics. They might be made of unusual materials, or have highly ordered structures, or exhibit properties that defy natural explanations. And this is where things get unsettling. A few years back, some researchers started noticing strange anomalies in ice core samples. They found unusual concentrations of certain elements, like titanium and tungsten, in layers dating back centuries. These elements aren't normally found in high concentrations in the atmosphere. At first, they dismissed these findings as contamination or experimental error. But the anomalies persisted, even after rigorous quality control measures. The researchers started to wonder if they were looking at something truly artificial. The problem is, we don't have a good baseline for what artificial nanoparticles from a long-lost civilization might look like. We're limited by our own understanding of nanotechnology. It's like trying to understand a computer built with alien technology using only your knowledge of abacuses. But there's more. Some of these nanoparticles appeared to be functional. They exhibited properties that suggested they were designed for a specific purpose. One researcher described finding particles that seemed to act as tiny antennas capable of absorbing and re-emitting electromagnetic radiation. Now, that's a pretty big claim, I know, but the data was compelling. The particles were too complex, too ordered, to have formed naturally, and their electromagnetic properties were unlike anything seen before. The implications, if true, are staggering. It would mean that a previous civilization had not only mastered nanotechnology but also deployed it on a massive scale. And it raises the question, what were they using it for? Were these nanoparticles designed for communication, for energy harvesting, for environmental modification, or something else entirely? We simply don't know. And here's what's potentially terrifying. If these nanoparticles are still functional, could they pose a threat? Could they be activated by modern technology? Could they interfere with our own systems? It sounds like science fiction, but we have to consider the possibility. After all, we're playing with incredibly powerful technologies ourselves. We're releasing nanoparticles into the environment without fully understanding their long-term effects. Are we repeating the mistakes of a previous civilization? What if those past civilizations collapsed because of unintended consequences from the very technologies they created? What if those nanoparticles aren't just inert remnants but ticking time bombs, waiting to be triggered? The research is ongoing, but it's slow and painstaking. Analyzing nanoparticles in ice cores is incredibly difficult. The particles are tiny, and the ice is often contaminated. But the potential payoff is enormous. If we can decipher the secrets of these ancient nanoparticles, we might gain valuable insights into the rise and fall of previous civilizations. And maybe, just maybe, we can learn something that will help us avoid a similar fate. The key is to broaden our search, to look beyond the familiar, to be open to the possibility that the past is far stranger and far more technologically advanced than we ever imagined. The answers, it seems, are frozen in time, waiting to be unlocked. Meanwhile, researchers have been looking at other types of evidence. Webb just revealed something massive. It's related to one of the strangest, most debated concepts in physics, quantum entanglement. You probably know it, the idea that two particles can be linked in such a way that they instantaneously affect each other, even across vast distances. Einstein famously called it spooky action at a distance. But what if quantum entanglement isn't just a property of subatomic particles? What if it can manifest on a much larger scale, influencing structures and even civilizations across time? Consider the possibility that the nanoparticles discovered in the ice cores weren't just passively floating around. What if they were actively linked, entangled in some way? What if their collective behavior was governed by quantum principles, allowing for instantaneous communication or coordination across vast distances? It sounds far-fetched, I know, but the more we learn about quantum mechanics, the more we realize that its principles aren't confined to the microscopic world. We're seeing evidence of quantum entanglement in biological systems, in photosynthesis, even potentially in the human brain. So why not in artificial nanostructures? Now, here's where it gets really interesting. If these nanoparticles were entangled, it would imply a level of technological sophistication far beyond anything we currently possess. It would mean that a previous civilization had not only mastered nanotechnology but also harnessed the power of quantum entanglement to control and manipulate matter on a massive scale. What purpose could such a technology serve? Well, imagine a global communication network built on entangled nanoparticles. Instantaneous communication across the entire planet without the need for satellites or cables. Or imagine a planetary defense system where entangled nanoparticles could be used to deflect asteroids or neutralize threats. But here's the potential downside. If this network were to malfunction, or if it were to be used for malicious purposes, the consequences could be catastrophic. Entangled systems are incredibly sensitive. A single disruption could cascade through the entire network, causing widespread chaos and destruction. Consider the implications for energy. Could a past civilization have developed an energy grid based on quantum entanglement? Harvesting energy directly from the quantum vacuum, perhaps? It sounds like science fiction, but the theoretical possibilities are there. And if such a system were to collapse, it could unleash unimaginable forces. This idea is radical, of course. There's no direct evidence to support it. But it's a thought experiment worth pursuing. We need to be open to the possibility that the laws of physics, as we understand them, may not fully explain the phenomena we're observing. Maybe the prehistoric world operated under a different set of rules, or perhaps a deeper understanding of quantum entanglement is needed. Further examination revealed something fascinating. When scientists subjected the nanoparticles to specific electromagnetic fields, they observed unusual patterns of behavior. It was as if the particles were responding to some kind of hidden signal. It's as if they were trying to communicate. The signal was faint and difficult to decipher, but it was there, and it suggested that the nanoparticles weren't just inert objects. They were active, responsive, and potentially intelligent. What would it mean if we could decipher that signal? What secrets would it unlock about the past? What if this signal is a warning? A warning about the dangers of unchecked technological advancement. A warning about the unintended consequences of playing with forces we don't fully understand. Scientists discovered that the nanoparticles exhibited a unique form of self-assembly. When placed in certain conditions, they would spontaneously arrange themselves into complex geometric patterns. These patterns were not random. They were highly ordered and symmetrical, suggesting a deliberate design. The implications extend beyond mere aesthetics. These patterns could be functional, serving as microcircuits or resonators. They could be designed to amplify signals, harvest energy, or perform other complex tasks. And here's what's wild. The geometry of these patterns bears a striking resemblance to ancient symbols and sacred geometries found in cultures around the world. Could there be a connection? Could these ancient symbols be a representation of the underlying quantum structure of the universe, a structure that was understood and harnessed by a previous civilization? This means that we might be looking at a civilization that had a fundamentally different understanding of reality than we do. A civilization that was able to bridge the gap between the quantum world and the macroscopic world, between the spiritual and the scientific. Imagine a world where technology and spirituality are not separate domains but are integrated into a single, unified system. A world where consciousness is not just a byproduct of brain activity but is a fundamental aspect of the universe itself. It sounds like something out of a science fiction novel, but who's to say it's not possible? Meanwhile, researchers are exploring the possibility that the nanoparticles are acting as a kind of time capsule, storing information about the past. They're analyzing the particles' structure and composition, looking for patterns and anomalies that could reveal clues about their origin and purpose. It's a painstaking process, but the potential reward is enormous. If we can unlock the secrets of these ancient nanoparticles, we might gain a deeper understanding of our own history, our own potential, and our own destiny. The answers, it seems, are not just frozen in time, but encoded in the very fabric of matter. The implications are pretty unsettling. We're not just talking about strange patterns on a microscopic scale. Consider the moon. It's been staring down at us for millennia, and we think we know it pretty well. But what if its very composition is a sign that something else was here first? Something advanced? For years, scientists have been puzzled by the moon's anomalous composition. It's not what you'd expect from a body that supposedly formed from debris blasted off the Earth after a giant impact. The standard model just doesn't quite add up. Let's examine the facts. The moon is surprisingly light. Its density is significantly lower than Earth's, suggesting a disproportionately small iron core. If the moon formed from Earth's mantle, as the giant impact theory proposes, you'd expect a much higher density. So, where did all the heavy stuff go? And that's just the beginning. The lunar crust is also unusually rich in certain elements, like titanium. Some lunar rocks contain concentrations of titanium that are far higher than anything found on Earth. What geological process could have produced such an extreme enrichment? It's a mystery. Then there are the strange isotopic ratios. Isotopes are different forms of the same element, with varying numbers of neutrons in their nuclei. The moon's isotopic ratios for certain elements, like oxygen, are almost identical to Earth's. This is often cited as evidence for the giant impact theory. But here's the catch. Other isotopic ratios are significantly different. For example, the moon is depleted in volatile elements like water and sodium compared to Earth. This suggests that the moon formed under extremely dry conditions, which is difficult to reconcile with the giant impact scenario. One explanation is that the moon formed from a completely different source material than Earth. Perhaps it originated in a different part of the solar system and was later captured by Earth's gravity. This would explain the differences in density, elemental composition, and isotopic ratios. But it also raises a new question. How did the moon get captured? Capturing a body as large as the moon is an extremely difficult feat, requiring a very precise set of conditions. It's not impossible, but it's highly improbable. Another possibility is that the moon was artificially constructed. I know, it sounds like something out of a science fiction movie, but hear me out. What if a previous civilization, far more advanced than our own, built the moon as some kind of giant engineering project? Maybe it was a base, a power station, or even a massive spacecraft. The hollow moon theory has been around for decades. It's often dismissed as pseudoscience, but it's based on some intriguing observations. During the Apollo missions, seismometers were placed on the lunar surface. When astronauts deliberately crashed the Apollo lunar modules into the moon, the seismometers recorded some unusual signals. The moon appeared to ring like a bell, vibrating for hours after the impacts. Now, this doesn't necessarily mean that the moon is hollow. It could simply be due to the moon's unique internal structure. But it does raise some interesting questions. What is the moon made of, and how is it put together? Further examination revealed that some scientists have proposed that the moon's unusual composition could be explained by the presence of vast underground caverns or voids. These caverns could have been created by mining activities or by some other unknown process. If the moon were hollow or contained large voids, it would explain its low density and its unusual seismic properties. And then there's the mystery of the lunar mascons. Mascons are regions of high gravity located beneath the lunar surface. They were first discovered in the 1960s, and their origin is still a subject of debate. Some scientists believe that mascons are caused by dense concentrations of heavy elements like iron and titanium. Others suggest that they are the result of ancient lava flows that have solidified beneath the surface. But what if the mascons are actually artificial structures? What if they are the remnants of some kind of ancient machinery or infrastructure? It's a wild idea, but it's not entirely out of the realm of possibility. The implications extend beyond just the moon itself. If the moon was indeed artificially constructed, it would have profound implications for our understanding of the universe and our place in it. It would mean that we are not alone and that other civilizations have existed and perhaps still exist that are far more advanced than we are. It would also raise some serious questions about our own future. If another civilization was able to build something as massive and complex as the moon, what are the limits of our own potential? What could we achieve if we put our minds to it? These anomalies, these strange compositions, these unanswered questions, they're not just scientific curiosities. They're potential clues, hints of a past that we're only beginning to glimpse. And the more we learn, the more we realize how much we don't know. The moon isn't just a rock in the sky. It's a puzzle, a mystery, and a potential window into a history that's far stranger and more complex than we ever imagined. What we choose to do with this knowledge, that's up to us. You've been told history is a straight line, a clear progression from simple to complex. What if that's wrong? What if civilizations rose and fell, leaving only whispers behind? Consider the countless myths and legends from cultures across the globe, tales of advanced beings, lost technologies, and cataclysmic events that wiped entire societies from the map. Are these just stories, or are they echoes of a forgotten past? We often assume that our current level of technological advancement is unprecedented. But the archaeological record is full of anomalies, objects, and structures that defy easy explanation. The Antikythera mechanism, for instance, a complex astronomical calculator dating back to ancient Greece. Who built it? And more importantly, what other technologies did they possess that haven't survived the ravages of time? Then there's the Baghdad battery, a set of clay jars containing copper cylinders and iron rods. Some researchers believe it could have been used to generate electricity, centuries before Galvani and Volta. If so, what was this power used for, and why did this technology seemingly disappear? These aren't isolated incidents. Across the world, we find evidence of sophisticated engineering, astronomical knowledge, and artistic skill that seems out of place in its historical context. The Nazca lines in Peru, massive geoglyphs that can only be fully appreciated from the air. The Great Pyramid of Giza, aligned with incredible precision to the cardinal directions. The Longyu Caves in China, vast underground chambers carved with intricate detail. The conventional explanation is that these achievements were the result of ingenuity and hard work, the product of civilizations slowly developing their skills over centuries. But what if there's another explanation? What if these are the remnants of civilizations that were far more advanced than we realize, civilizations that possessed knowledge and technologies that have been lost or deliberately suppressed. The problem is the evidence is often circumstantial, fragmented, and open to interpretation. Mainstream science is hesitant to embrace theories that challenge the established narrative, especially when those theories involve the possibility of lost civilizations or advanced ancient technologies. The burden of proof is high, and the skeptics are quick to dismiss anything that doesn't fit neatly into the accepted framework. Consider the Younger Dryas impact theory. This theory proposes that a large comet or asteroid struck the Earth around 12,800 years ago, causing a period of abrupt climate change that wiped out many species, including the Clovis culture in North America. Proponents of the theory point to evidence of impact craters, nanodiamonds, and other unusual geological formations as support. Critics, however, argue that the evidence is inconclusive, that the impact craters are not definitively linked to the Younger Dryas event, and that the nanodiamonds could have been formed by other processes. The debate continues, with both sides presenting their arguments and counterarguments. But what if the Younger Dryas event wasn't just a natural disaster? What if it was the final blow to a civilization that was already in decline, a civilization that had achieved a level of technological advancement that we can barely imagine? It's a speculative idea, but it's not entirely without merit. The archaeological record is full of gaps and inconsistencies, periods of rapid cultural change that are difficult to explain. It's possible that some of these gaps represent the collapse of advanced civilizations, civilizations that were erased from the historical record by natural disasters, warfare, or some other unknown catastrophe. And then there's the question of intentional suppression of knowledge. Throughout history, there have been instances of books being burned, libraries destroyed, and ideas censored. What if some of this destruction was aimed at eliminating evidence of advanced ancient civilizations, civilizations that challenge the prevailing worldview of those in power? It's a disturbing thought, but it's not entirely implausible. The control of information is a powerful tool, and those who wield it are often willing to go to great lengths to maintain their authority. The implications extend beyond just the realm of archaeology and history. If advanced civilizations have existed in the past, it would challenge our understanding of human potential and the trajectory of technological development. It would force us to reconsider our place in the universe and our relationship to the past. Further examination reveals something else. We may be looking at this all wrong. Perhaps we're focused too much on technology as the sole marker of advancement. Maybe these civilizations possessed a deeper understanding of the universe, a different kind of wisdom that we have yet to grasp. What if their technology was something we wouldn't even recognize as such? Scientists discovered that the search for these lost civilizations isn't just about finding artifacts and ruins. It's about challenging our assumptions, questioning the established narrative, and being open to the possibility that the past is far more complex and mysterious than we ever imagined. The implications extend to how we view our future. What if our entire reality is a simulation? It's a question that's been relegated to science fiction for decades, but in recent years, some scientists and philosophers have begun to take the idea seriously. It's called the simulation argument, and it offers a completely different lens through which to view the possibility of advanced civilizations. The basic premise is this: if a civilization were to reach a point where they possessed the technological capability to create realistic simulations of their ancestors, they would likely create many such simulations. In fact, they might create so many that the vast majority of people would actually be simulated beings living in simulated worlds. Consider the trajectory of our own technology. We've gone from simple computer games like Pong to incredibly realistic virtual reality experiences in just a few decades. If this trend continues, it's not unreasonable to imagine a future where simulations are indistinguishable from reality. And if that's possible, then it raises a profound question. How can we be sure that we're not already living in a simulation? It sounds like something out of the Matrix, I know, but the argument isn't based on science fiction. It's based on probability. The probability that advanced civilizations exist. The probability that these advanced civilizations would develop simulation technology. And the probability that they would actually use that technology to create simulations of their past. If these probabilities are high enough, then it becomes more likely that we are living in a simulation than that we are living in the base reality. It's a statistical argument, not a technological one. This idea, popularized by philosopher Nick Bostrom, suggests three possibilities, each presented as a trilemma. 1. The fraction of human-level civilizations that reach a stage where they are capable of running high-fidelity ancestor simulations is very close to zero. 2. The fraction of post-human civilizations that would choose to run ancestor simulations is very close to zero. 3. The fraction of all people with our kind of experiences that are living in a simulation is very close to 1. Bostrom argues that at least one of these statements must be true. If the first statement is true, then humanity is unlikely to reach a post-human stage. If the second statement is true, then even if humanity reaches a post-human stage, it is unlikely to run ancestor simulations. Therefore, the most likely scenario is the third statement, that we are living in a simulation. Now, let's be clear, there's no definitive proof that we're living in a simulation. But the argument is compelling enough to warrant serious consideration. And if it's true, it has profound implications for our understanding of the universe and our place in it. It could explain why we haven't detected any other advanced civilizations in the universe. Perhaps they're all simulations too, running on different servers, so to speak. Or maybe the creators of our simulation have deliberately prevented us from discovering them. It might also explain some of the weirdness of quantum mechanics. The act of observation seems to affect the behavior of subatomic particles. Could this be a consequence of the simulation's code, rendering reality only when it's observed to save processing power? It sounds far-fetched, but some physicists have entertained the idea. If our reality is a simulation, it would also reshape our understanding of time and space. These could be constructs, limitations imposed by the simulation's designers. What we perceive as the vastness of the universe might just be a carefully crafted illusion. Further examination reveals something else. If we are in a simulation, then the search for lost civilizations takes on a whole new meaning. Perhaps the horrifying aspect isn't the existence of superior beings in the past, but the realization that those beings are our programmers. And what if they are running multiple versions of civilization, tweaking parameters, observing the outcomes? Maybe our history isn't a linear progression, but a series of experiments. Those gaps and inconsistencies we see in the archaeological record. Perhaps those are instances where the programmers intervened, rebooted a section of the simulation, or simply patched a bug. Consider the implications for free will. If our actions are predetermined by the simulation's code, do we truly have a choice? Are we just sophisticated automatons, acting out a script written by someone else? This is a question philosophers have wrestled with for centuries, but the simulation argument gives it a new, unsettling twist. The simulation argument isn't just a philosophical thought experiment. Some physicists have proposed ways to test whether we're living in a simulation. One idea involves searching for subtle glitches or anomalies in the fabric of space-time, imperfections in the simulation's code. Another involves looking for patterns in the cosmic microwave background radiation, remnants of the Big Bang. These are highly speculative ideas, of course, but the fact that scientists are even considering them shows how seriously the simulation argument is being taken. The implications extend beyond just the scientific and philosophical realms. If we are living in a simulation, it could have a profound impact on our ethics and morality. How should we treat each other if we know that our actions are ultimately meaningless? What is the point of striving for greatness if our achievements are just lines of code? It's a disturbing set of questions, and there are no easy answers. But perhaps the very act of grappling with these questions can help us to better understand ourselves and our place in the universe. Or, in this case, the simulation. The search for lost civilizations might ultimately lead us not to the ruins of the past, but to a confrontation with the architects of our reality. It forces us to consider what we value, what gives our lives meaning, even if that meaning is ultimately artificial. The analysis continues. 730 exoplanets, all of them defying our current models of planetary formation. We've been operating under certain assumptions about how solar systems come into being, assumptions that seemed pretty solid. A star forms, a protoplanetary disk swirls around it, and gravity does its thing, clumping together dust and gas to create planets. The further out you go, the colder it gets, allowing icy giants to form in the outer reaches, while rocky planets coalesce closer to the star. Easy, right? Except that's not what we're seeing. Not even close. These exoplanets, discovered by missions like Kepler and TESS, are throwing a wrench into everything. We're finding gas giants orbiting incredibly close to their stars, hot Jupiters that shouldn't be there according to the standard model. We're seeing planets with wildly eccentric orbits, planets orbiting backwards, planets that are far too big for their stars, and planets with densities that simply shouldn't exist. The list goes on and on. What if our fundamental understanding of planet formation is just wrong? What if these rogue planets aren't anomalies but are actually the norm? What if the solar system we see is some sort of exception to the rule? Scientists discovered that there are free-floating planets. Planets not orbiting any star at all, numbering in the billions. Where did these come from? Did they form in isolation, or were they ejected from their star systems? It raises profound questions about the very nature of cosmic evolution. Are we looking at a universe teeming with far more diversity and complexity than we ever imagined? The current models are based on observations within our own solar system, but what if our solar system is atypical? What if it represents a relatively stable and well-behaved system in a universe that's far more chaotic and dynamic than we previously thought? It's like trying to understand the ocean by only studying a single tide pool. You might get a decent understanding of that specific environment, but you'd be missing the bigger picture, the vastness and unpredictability of the open sea. Further examination revealed that the problems extend beyond just planet formation. We're also seeing anomalies in the distribution of dark matter, the expansion rate of the universe, and the behavior of certain types of galaxies. These discrepancies are forcing scientists to re-evaluate some of the most fundamental assumptions about the cosmos. Consider dark matter. We know it's there because we can see its gravitational effects on galaxies, but we have no idea what it actually is. Current models suggest it should be evenly distributed throughout galaxies, but observations show that it's often clumped together in unexpected ways. Is it possible that dark matter isn't what we think it is? What if it's something entirely different, something that requires us to rewrite our understanding of physics itself? Then, there's the accelerating expansion of the universe. We know that the universe is expanding, but its expansion is speeding up, driven by a mysterious force called dark energy. The amount of dark energy we observe is far greater than what our current models predict. Measurements showed that it is so large that some physicists are exploring alternative theories of gravity, theories that could explain the accelerating expansion without the need for dark energy. These are radical ideas, but they're being taken seriously because the current model simply doesn't fit the data. And what about those ancient myths and legends, the stories of advanced civilizations that supposedly existed long before our own? Could there be a kernel of truth in those tales? Consider this. What if a previous civilization was wiped out by some cataclysmic event, an event that erased almost all traces of their existence? What if the only remnants of their civilization are the enigmatic structures and artifacts that we're still struggling to understand? It's a long shot, of course. The evidence for such a civilization is circumstantial at best. But in a universe full of surprises, it's important to keep an open mind and to consider all possibilities, no matter how improbable they may seem. The implications extend beyond the scientific realm. It touches upon our very sense of identity, our place in the cosmos. If we're not the first, if we're not alone, what does that mean for our future? What responsibilities do we have to the universe and to ourselves? It forces us to confront our own limitations, our own biases, and our own assumptions. It reminds us that the universe is vast and mysterious, and that there's always more to learn. What if the search for lost civilizations is ultimately a search for ourselves? A search for our origins, our purpose, and our destiny? It's a journey that will challenge us, inspire us, and ultimately transform us. It's a journey that will lead us to the very edge of knowledge and perhaps beyond. And who knows what we'll find there? Want to keep exploring mysteries? Don't forget to subscribe and drop a comment of what you have to say.